As we advance to some more interesting dimensional analysis problems, we need to introduce an intrinsic property. Intrinsic properties are things about the identity of a chemical that we can use to figure out what it is. This could be density or hardness or color. For now, density is going to be the most interesting one that we have to talk about. If we look at a graph of a particular compound's mass and volume, we could measure the volume of an object. If it was three-dimensional, like a box, we could use a ruler and we could measure out the length and the width and the height of that object and multiply those three things to get the volume of the object. We could also take a smaller portion of that and use a technique called volume displacement to see how much volume was in a container. Basically, you would have a larger measuring device, like a graduated cylinder, filled with a certain amount of water. And when you put the object with an unknown volume into the water's level will raise. We would then look at the difference in the measurement, that change in volume, and then we could plot it on the graph. We would get mass values in a pretty standard way by using a scale. So let's say we have this green stuff and we found that there were a bunch of different volumes and they had different mass amounts. We could also measure any other kind of material, and let's say those would have values that looked like this. Okay, so that seems like a pretty straightforward graph. We'd see a relatively linear relationship between all of these green dots and all of the blue ones. Okay, so what does this linear relationship mean? It means that no matter how much stuff you have, that you're going to have the same rise over run going from one sample of material to another. If you take the slope of this graph, the slope being the rise over the run, you would end up with units that look like mass divided by volume. And most of us know from middle school that mass divided by volume is density. So what we can use is this linear relationship between the mass and the volume to change those units into each other. Let's do a practice problem. Okay, let's take a look at this question. The density of pure silver is 10.5 grams per centimeters cubed. When I see that density, I see a ratio or an equivalency that I can use later on. It's kind of like saying 10.5 grams of silver is equal to 1 centimeter cubed of silver. So I can use an equivalency, like a fraction in my dimensional analysis, of either 10.5 grams over 1 centimeter cubed, or I can also use this, if I need to get rid of grams later, as 10.5 grams per centimeter cubed, but upside down. Since these two quantities are the same thing with different units, it doesn't matter if I have the numbers and units on the top or the bottom. Okay, the next chunk of information says if 7.26 grams of pure silver is added to a graduated cylinder containing 13.5 milliliters of water, to what volume will the water in the cylinder rise? Okay, so here's my plan. I have my known water amount, my known milliliters, 13.5. And I don't know how much I'm adding to get my new total. Okay, so my question's really asking me, what volume amount is my pure silver sample going to take up? So here's what I do. I'm going to write down my given number, 7.26 grams of pure silver, And then I'm going to see how I can change those grams into a volume amount. Using my density, I can change my mass into a volume unit. It's not the volume unit I'm looking for, but it's a good first step. All right, so here's what I'm going to do. I'm going to choose to use the second fraction because then my 10.5 grams is going to be on the bottom, canceling out my gram units. I'll put my centimeters cubed on the top. Then I need to check a formula sheet or a table of equations in the back of a textbook to double check that 1 centimeter cubed is actually the same thing as 1 milliliter. Okay, then I'll use my dimensional analysis tricks and make sure that all of the units I do not want are canceled out, ending in milliliters. And I get an answer of something, wow, this is a really fun number to write down. I'm going to do the whole thing. 0.619142857. That's a little ridiculous, but we'll keep it for now. Okay, though this is a really fun answer, it's not actually the answer to the question yet. We really want to know the new total of the volume. So I'm going to take that original 13.5 milliliters and add it to this new number in my calculator, the 0.69 and change. And in my calculator, the answer looks like 14.1914257 on forever. This is really, really ridiculous number. Okay, let's check some sig figs so we can round. It looks like there's only one decimal place in that 13.5, so that's where I need to cut my answer off. I see that the number next to that 1 is a 9, so I'm going to round this to 14.2 milliliters. Make sure that you always report your answer with the units and then double check that we are answering the question.